Good afternoon, everyone. Thank you for joining us today. Very excited to get stuck into this one with you all, but we're just going to wait for another minute or two for to give people a chance to join us, and then we'll get stuck into it. Thanks, gang. Alrighty, everyone. Thank you for standing by for a moment while we just wait for a few people to join. Yeah, thanks again for joining us today. My colleague Josh, who's assisting me with the webinar today, he just gave me the all clear to get started. Um, I guess quick little intro for myself here. So for those of you who haven't spoken with before, my name's Elliot. I'm the chief remote pilot here at Sphere Drones. I've been here for about 8 years, and it's been a pretty interesting ride seeing all of the changes to the industry over the years. But yeah, really appreciate you taking the time to join us today. So today, the agenda for what we'll be running through is, based on the fundamentals of drone-based surveying techniques. I guess the intention of today is to look at it from a relatively high level for those of you who maybe haven't been exposed to drone surveying before, and maybe to kind of recap some of the things that are useful to keep in mind when you are early on in your journey of the drone-based space. So we'll be looking at the basics of drone-based surveying, equipment required for drone-based surveying, a brief look at photogrammetry and lidar and what they are, some of the planning and execution of drone-based surveying operations. We'll briefly touch on ground control points, and then a couple of case studies there on mapping and lidar. If people have any questions throughout the session today, please feel free to shoot them through in the questions section there. Josh will be keeping an eye on that one for us, and we'll be reviewing the questions at the end. And if we don't get a chance to go through every question, then we'll certainly circle back. And we always welcome any questions that do come to you off the back of the webinar. Please feel free to shoot them through to us, and we can kind of connect on that after the session. So without further ado, the basics of drone surveying. There are two primary drone surveying techniques that we'll be talking about today, primarily photogrammetry and LiDAR. There are, of course, a couple of tangential, surveying principles, including things like, magnetometer surveys and things like that, which we won't go into today, but there are, of course, other technologies and use cases that do kind of fall under this category. But of course, one of the main things around the use of drones is being able to, extend your operational range. So typically, if you're having to do a survey on foot, it might take you a fair while, or if you were relying on satellite-based imagery or whatever, then it might be something where you don't quite get that resolution that you want. There's of course safety benefits to it, of course. So, bringing a drone into the mix can, of course, change some of the risk profile to, reflect the fact that you have an aircraft up in the air. But those risks are somewhat nominal in the grand scheme of things by comparison to, the potential for, slips, trips, falls, injury, fatigue, heat stroke, and, incidents with, snakes or other hazardous wildlife, etc. So, being able to remove people from those hazardous environments in a mine site, like being away from the big haul trucks and diggers and things, really enhances safety in a lot of ways. So that's one of the big values for a lot of people too, on top of the efficiency. So some of the applications, just a couple of the applications you can see there, construction, mining, agriculture, and utilities, but the list really is incredibly comprehensive. So realistically, there's huge utility for a wide variety of drone technologies in almost every industry. So it's a pretty exciting time to be in the drone space there. So in terms of the equipment required for drone-based surveying, so this is of course no means a comprehensive list that covers everything, but just as a quick kind of starting point, I suppose. Some of the key equipment is, a drone and a payload. So we've got an example there of the Mavic 3 Enterprise, really, really capable little unit. Being able to travel around with that thing in your bag or in your small vehicle, etc., is just really convenient, quick to set up, quick to deploy, and captures really good quality data. In some instances, you might need a little bit more of a capability, so you might need to step up to something like the P1 there. That's obviously a full frame camera with interchangeable lenses. So it's a little bit more powerful is probably the simplest way to put that. The Matrice 300, of course, also has some benefits in being able to have that flexibility of, utilizing the P1, and then you can swap it out for a different payload if you want to do a close-up inspection work, or maybe you want to do a LiDAR mission the next day. Being able to use one platform with multiple payloads is quite advantageous in a lot of scenarios. So we've also got on the right-hand side there the Matrice 300 with the ZenMuse L2. So really, really good LiDAR unit, user-friendly, intuitive, very streamlined, and good quality of data. So we've got the base station here as well. So while it's not strictly required to use a base station, there are big advantages to having, improved positional accuracy on the drone, which then also can translate through to better quality of data as well. There is also another consideration in terms of safety. Being able to utilize an RTK base station like the DRTK2 or an MLID Reach, for example, really allows you to have that operational certainty that the drone is going to fly in a stable and safe way, even if there are, potentials for compass interference on site, etc. And then generally as well, a software to post-process the data after the fact. So you can see here we've got DJI Terra and Pix4D Mapper. Again, by no means an exclusively comprehensive list, but they're some of the common processing softwares that are used by industry. Pix4D Mapper's got a very wide user base, which has a lot of really useful information and forum support and all that sort of stuff. So there are some nice advantages there. And then, of course, with DJI Terra being the native software that's included, there are, of course, benefits there to using the DJI own system. So a brief look at photogrammetry here. So photogrammetry is, of course, the process of taking measurements from photos to create accurate 2D maps, 3D models, or orthomosaics. So effectively, it's capturing a number of different photos and stitching them together, finding the common points in those images, and using that to create basically a real-world model. So the benefits of photogrammetry, of course, is that it's highly accurate in both 2D and 3D. There's reduced time for land surveys by comparison to traditional means. And then having that integration with with CAD and GIS systems, etc., is really handy to enable you to successfully incorporate the data that you've captured in with your other metrics that you might need to be comparing it against, so your plans, etc. So you can see again applications. Some of the key applications here are urban development and planning, infrastructure inspections, disaster recovery, like landslide or flood mapping, and mining, of course, geological mapping and pit volume measurements are just a couple of the examples. But again, really the applications are incredibly varied and there's a lot of utility for photogrammetry in a number of different environments. One kind of limitation, I suppose, of photogrammetry as a kind of broad view is that the photogrammetry as a technology generally doesn't favor environments like heavily vegetated environments or water. They do kind of struggle a little bit in those sorts of environments. So just something to kind of keep in mind there. But effectively, as you can see here in the top corner, we've got flying pre-planned missions over the site. So you can plan before you head out in the field in a lot of situations. You can see pictured here is a double grid, which is particularly useful if you're doing 3D modeling. But often a lot of people will just use a single grid rather than doing the crosshatch that you can see here. You can see there the capturing of the overlapping images. So you can see each of these little green triangles in the image here does relate to a point where the drone captured an image. And so that's kind of where the camera was at that point in time. So being able to position all of those points is part of the foundation, I suppose, of photogrammetry. And then you can see here, you can process that data into 3D models or other deliverables using software like DJI Terra or Pix4D that we mentioned before. So LiDAR is a really interesting technology. One of the big things with photogrammetry is that it's using a traditional camera, whereas a LiDAR payload is what's often referred to as an active sensor rather than a passive sensor. So effectively, it's shooting out a beam of light and waiting for that light to return, and then calculating how far away the surface was based on how long it took the light to travel. So one of the big benefits with LiDAR specifically is that you don't actually need daylight to fly, which can be a big advantage in some scenarios. You might be that you have an airport in the area and maybe that closes at a particular time. And so then you're able to, operate the drone after hours where there's, no aircraft traffic or, lower population density, etc. So, and you're not as beholden to the ambient light in the environment, which is pretty handy. So it has also been used underground, which is a topic for another day. But yeah, LiDAR is a really interesting technology. So one of the big benefits, of course, is that you do have that ability to penetrate vegetation. So you can see here, there's a thumbnail there of a pretty heavily vegetated environment, and being able to understand where the ground level is at any point in that environment is really handy. You can see here, of course, it does have exceptional accuracy for elevation and surface modeling, and fast data acquisition for large areas is another benefit of the LiDAR payload as a principle. And more than just the fast acquisition, but also the fast turnaround time on the data processing side of things is quite advantageous. So being able to have a reduced turnaround time can mean that you can make actionable you can make decisions on the data that you've captured far more quickly because you're not having to spend a large amount of time waiting for data to process. So basic workflow, you secure the LiDAR payload with your drone, you fly over the target area to collect dense point cloud data, and then you process that data into the format that you require, whether that's a digital terrain or surface model, digital elevation model. Maybe you want the raw LiDAR point cloud data, and you can make, again, those informed decisions on volume calculations or things like that. One of the other kind of applications that you can see down the bottom here, so we've got the mining application, of course, being able to understand the volumes of stockpiles that you might have on site, or the health of your benches in your mining environment there, or your haul roads, etc. You can see here the utilities. So one of the big things with LiDAR is that it is very useful for being able to get those multiple returns, which can be very, very helpful for power line health. So if you have power line sag, etc., sometimes utilizing a very accurate, very precise LiDAR can allow you to calculate whether you need to do maintenance on your pole infrastructure, etc. So some interesting insights there in the utility sector. And from a safety perspective with the utilities, being able to ensure, for example, that the vegetation encroachment hasn't increased around your power lines means that you can plan more effectively for arborists to come in and maintain the trees around your power lines. And you've probably all seen some of the archaeological utilization for LiDAR, which is pretty exciting. Being able to scan a dense, rainforest environment and identify the extent of a lost city is, something out of Indiana Jones. So pretty cool to be able to get insights like that. So in terms of planning and executing drone-based surveying operations, of course, having the right certification and qualifications is, always a very good start. Ensuring that you've got the right licenses and doing any relevant training courses, etc., from a safety perspective, but also from getting the most out of your systems. So ensuring that you're familiar with the workflows, etc. And then I guess in terms of the step-by-step process there, being able to determine the type of data that you're looking for will also kind of be shaped to some extent. It will also shape what sort of payload and drone you might go with. So you can see pictured here on the left, we've got the DJI Matrice 300 series with a yellow scan mapper plus. So that's capturing a LiDAR data set as well as a camera being mounted on the back for photogrammetry purposes, and then you can colorize your point cloud as well as create an orthomosaic or whatever you want to do. So having that understanding of what you're actually setting out to achieve will be quite important for how you actually execute your mission. So site preparation, so ensuring that you're aware of the risks and the hazards on site is, of course, very important when you're operating drones. Not having to trudge through, dense undergrowth of, vegetation or scrubland, etc., is, of course, nice, but it's important to ensure that you're, not flying too low around an environment where there might be power lines, etc. So having that site preparation completed is very important. You can see, of course, we've also got the review local regulations, so that may extend to things like, landholder permissions if you need to launch and land from someone's property, or maybe you're operating in proximity to, a military base, so ensuring that you get the appropriate permissions to operate in restricted areas, etc. All kind of falls into that. Mission planning. So, of course, mission planning has become relatively easy in the grand scheme of things. There are still benefits to planning ahead and having a rough idea of the sort of planning that you're going to need to do for a particular site. But it is something that more and more we are seeing can be done in the field to an extent. But there might be things like ensuring that you've got a KML of your area of interest so that you can ensure proper coverage of the entire site. It might be something where you want to ensure that you've got, the map layer on your GPS window. I'm sorry, I've lost the terminology at the moment, but effectively ensuring that you have those base maps loaded on your device before you go out in the field can ensure that you're flying over the area that you think that you're flying over based on what you're seeing in the real world, lining up with what you see on your remote controller. Calibration of the equipment, ensuring that it's all in good working order, of course. With some solutions, they do require a calibration either before they are utilized for the first time, or maybe they require a calibration maneuver to be done before and after each flight. That's often something that we see with LiDAR technologies. You need to do that LiDAR calibration before and after each flight. It's only a short maneuver, but it is something that needs to be done there. And then and then collecting the actual data itself. So conducting the flight, ensuring you've got the correct data overlap and consistent altitude. So it might be something where you want to utilize terrain following, or it might be something where you have kind of factored in the consideration for changing terrain, etc., that might affect your overlaps or your resolution. And so once you've captured the data, heading back to the office and post-processing the data, or in some cases there are even the ability to have things processing in the cloud, which is pretty exciting. Some of the other key considerations that you can see up the top here include weather conditions, so ensuring that you've checked the forecast to make sure that you're not going to get caught out in the rain. Often drones do have IP ratings these days, but it is still something where the data quality can be affected if you are flying in inclement weather. LiDAR is obviously something that does suffer from noise if you do fly in an environment where rain is occurring while you're flying, and it can also introduce some noise to the data with it playing havoc with the light waves. And then battery equipment and readiness. Battery and equipment readiness. So ensuring that your batteries are all charged. They often batteries these days do self-discharge, so ensuring that you do charge them up, in close proximity so that they don't start to self-discharge before your flight, but also just ensuring that your maintenance and all that sort of stuff is done as well, of course. In terms of types of processed data outputs, so you've got a couple of examples here. Again, by no means an exclusively comprehensive list, but 2D ortho mosaics are often used on site to get a current and updated site plan, being able to have people obtain an awareness of what the site actually looks like from above can help provide that context. 3D point clouds, of course, you can see a LiDAR point cloud data set there. We've got the digital elevation model on the right, and of course there are digital terrain models and digital surface models as well. So depending on whether you've got structures in there or if it's natural terrain. Volume calculations, high resolution imagery for reporting, and then contours are something that are often used for things like water, runoff modeling, etc. So a wide variety of data outputs there. We're not going to go into too much detail on the concept of ground control points because we could be here all day talking about ground control points, but from a very high level, basically ground control points are marked points on the ground where the coordinates are known. So being able to use them as a precise reference point, and having them spread out across your site, you can accurately model a large area with a high degree of accuracy, and I guess it also acts as a sort of fact check, ensuring that you're truthing the data that you're capturing. They're used to ensure correct scale, orientation, or absolute position of a captured site. By placing them around the outside of your operational area and then smattering them through the middle, it allows you to ensure that when the photogrammetry or LiDAR data is being post-processed, you're able to ensure that it's conforming with the actual real-world environment rather than being in an arbitrary space, if that makes sense. So, of course, the benefits, like I've spoken about, increased accuracy and precision, and then allowing it to be transformed to align with the coordinate reference system of your choice. So, a couple of example case studies here. So, a mining company in Western Australia needed to perform detailed topographic surveys across a 500-hectare open pit mine. So traditional survey methods were time-consuming and posed safety risks to staff navigating uneven terrain. Of course, not to mention the risks of haul trucks, etc., and all the kind of wildlife that we have in Australia here. So the solution, of course, was to look at a Matrice 350 RTK equipped with a Zenmuse P1. So it was deployed to capture high-resolution photogrammetry data. The P1's full-frame sensor enabled the collection of precise aerial imagery, while the RTK module ensured centimeter-level accuracy. So the mission was planned and executed using DJI Terra software for optimal efficiency. Switching to the Matrice 350 enabled them to streamline the workflow and promoted a safer and faster data collection. And they used the accurate topographic data for operational planning, resource estimation, and environmental compliance. So any scenario where you need to capture imagery of your environment, the Matrice 350 and P1 are going to do a fantastic job there. And as I said before, having that flexibility of mounting other payloads underneath just really allows a bit of a Swiss Army knife approach, if that makes sense. LiDAR application here. So we had a construction firm that needed to conduct a site survey for a major infrastructure project. So having that ability to go and scan an environment as a greenfields project and get an understanding of the environment before you start, and then monitoring the progress and ensuring the compliance with design specifications. It worked really well in both the urban and wooded sections. So sometimes, obviously, as I mentioned previously, the traditional survey methods can, sometimes be a little bit more challenging in some of those environments. So the Matrice 350 with the L2 was deployed to create high-density 3D point clouds of the site, and the L2's ability to penetrate vegetation due to the fact that it's a LiDAR sensor, provided detailed elevation models and identified hidden ground features. So the data was processed to generate digital terrain models and contour maps for project planning. And as you can see there, the result was that the drone solution provided a comprehensive view of the construction site, supported progress monitoring, quality control, and design verification. So the accurate models were also used to identify potential site issues early, improve planning, and streamline communication between project stakeholders. So Yeah, the L2 is a really nice piece of kit. You know, having a live view of the LiDAR point cloud as it's capturing is really neat, and having that ability to capture, high resolution imagery with that built-in camera is really handy as well. If it is something where an improved, a higher resolution or, sorry, rather a higher accuracy or precision is required, then it is something where one could step up to something like the Surveyor Ultra by Yellowscan. That one has a 360-degree scanner, and you're looking at a really nice tight precision and accuracy, really good vegetation penetration, and a 61 megapixel, sorry, integrated camera, or you can use a dual oblique camera as well. So some really nice options are available there on the market at the moment. But that's essentially it for the bulk of today. But I wanted to open the floor to questions. So I'm not sure if anyone has any questions about anything that we've spoken about so far, or if there's anything that anyone would like to see in future webinars. Please feel free to shoot them through via email. I'll just jump over to the next slide. So that you can see that contact information there. But yeah, keeping that channel open for questions at the moment. Is there anything that anyone wanted to ask about the fundamentals of drone-based surveying? Not having anything come through at the moment, gang. So I can see a clapping emoji. Thank you, Mikhail. Good question. So we've just had a question come through about the use of surveying for wildlife using thermal cameras. So the short answer to your question there is essentially that as long as your wildlife isn't actively moving too much throughout the site, then the methodology that I mentioned a moment ago should be relatively effective. The main thing to be mindful of is that it will depend a little bit on the environment that you're in and the wildlife that you're looking for. So one of the popular applications recently was the use of thermal cameras to look for koalas in Australia. One of the challenges of the surveying of koalas, for example, is that if you have a koala that is underneath a dense canopy, a thermal camera can only identify a subject that is not obstructed by something. So, for example, the koala that's behind, dense vegetation may not stand out very well. But if you were, flying lower and slower, and you were manually flying, you would certainly be able to identify that wildlife a little bit more easily. If it was something where you were doing, a survey of a field where you had cattle, for example, if the cattle were sleeping because it was, the like nighttime, for example, then you might have that ability to do a survey mission on an area and get a reasonable understanding of what your livestock are from a quantity perspective or a location perspective. But the tricky thing is if they're moving, you might end up with duplicates, if that makes sense. But again, Rai, if you want to follow up on that one off the back of the session, feel free to reach out to the team. So we've got a typical height for flying for mining topo survey, and what about uneven hilly ground, say 15 meters change in height? So Gary, that's a great question. I guess the main thing to be mindful of there is that if you do have a significant change in terrain elevation, then it's something where that can affect your overlaps or your resolution. So in an ideal world, you would set your overlaps in a conservative enough way that you would potentially be capturing enough imagery with enough overlap so that it doesn't necessarily matter quite so much. Obviously, there's a fine balance between efficiency and operational certainty. 15 meters change in height, I wouldn't expect that to be a huge issue unless you were flying very low. So depending on what your requirements are from a resolution perspective, often a lot of our clients will operate at that kind of 120 meter mark, even with something like a Mavic 3 Enterprise. But it is something where if you have, say, if you had your overlap set a little bit low and then you didn't factor in for that change in elevation, then that's where you can get caught out and you might find that you have holes or gaps in your data. So, yeah, if you want to shoot us through an email off the back of the call, though, Gary, we can have a bit more of a conversation with you. And we've got a number of clients that would be able to provide some feedback around what their kind of standard is on site. So I'd be happy to have that conversation with you there. What is the quality difference between the Mavic 3 Enterprise versus the Matrice 350 RTK with respect to photogrammetry data? Thanks for the question, Andrew. So the short answer is, as a solution, they both are very high quality, and I think that it ultimately comes down to the workflow and what you need or want to do, what sort of area you want to cover, etc. And if you have any requirements for licensing and certification. One of the beautiful things about the Mavic 3 Enterprise series is that it is in that sub 2 kilo category, so you can operate that unit under an excluded category certification. If you do have a need to get higher resolution imagery, obviously, I think it's a 45 megapixel camera on the P1. Versus I think it's a 20 megapixel camera and a smaller sensor on the Mavic 3 Enterprise. So there are benefits to stepping up to the P1 in that regard, but it is something where the Mavic 3 Enterprise might be a simple and effective tool. So it's a little bit subjective. I'm sure we've probably got a number of people on the call today who have one or the other or both, and they're probably saying, this is why I like this one, or this is why I like that one. But yeah, again, if you have questions on that one, feel free to follow up with us off the back of the call, Andrew. Simon, so how is the DJI Dock 2 integration with surveying? The short answer for you there, Simon, is it's great. The long answer is that the Matrice 3D is it's very similar to the Mavic 3 Enterprise in a lot of ways, but having that ability to have the drone being operated remotely from a remote operation center, can present a huge amount of efficiency gains, etc. Yeah, so the short answer is it's been designed specifically to cater for that surveying application. So yeah, if you have further questions on that, feel free to reach out. Ground control points. Good question there from Nick. So in terms of the RTK ground station, there's a couple of different options. You might have seen in the slides that we had a picture of a propeller aero point. So that's a smart ground control point. Rather than needing to use a survey base station and rover to identify the exact coordinates of the ground control point, that solution will sit there and log its position for about 45 minutes. Or I think it might even be less actually with the newer versions. But the short answer is, yeah, you do use an RTK survey-based or rover to capture that ground control point. But again, if you have further questions on that, Nick, just reach out. Happy to help. Nikita, what kind of payload was used for the LiDAR case study? So in terms of the options that we support at the moment, obviously the L2 is DJI's latest solution. Really nice, integrated, streamlined workflow. The other option that I mentioned there, Nikita, was the Yellow Scan lineup. So the Surveyor Ultra is the kind of the flagship from Yellow Scan, really, really good vegetation penetration. That's the Surveyor Ultra that I was referring to there. So yeah, if you do have any further questions on that one, Nikita, feel free to reach out. We can have a look at your specific use case. Interesting question there from Tim. Thanks for that one, mate. So the question is, can a receiver from a robotic total station be used for the base station or only a specialized DJI base station? So the simple answer to your question is that DJI solutions do enable you to use a number of different options from when it comes to base stations. The DJI DRTK2 is the solution from DJI, but they do have the ability to use an N-chip based solution. Probably best for us to take that conversation offline rather than go down a bit of a rabbit hole today. But yeah, happy to have a chat with you on that one, Tim. Peter has asked a question about whether thermal cameras could be used to find weak spots in concrete towers or leaks in weirs, etc. So that's a great question, Peter. Obviously, the premise of a thermal camera is that it picks up, the emissivity of it, or sorry, the reflectance of a surface that it's inspecting. So if, for example, you had a leak in a weir and that resulted in a temperature difference or a reflectance difference, you might be able to identify that. But it is something where there are a number of other technologies which are used for identifying defects in concrete towers. So recognizing your company, if there is something where you wanted to have a bit more of a chat, we're more than happy to jump on a call. So feel free to reach out, Peter. What else have we got here? So I think those are most of the questions that we've got at the moment, team. It was really lovely to chat to you all. If there's anything else that you think of, feel free to shoot us through an email off the back of the call, sorry, off the back of the session. The email address is there on your screen, and the phone number's there as well. So feel free to pick up the phone if you like. But look, stay tuned. We'll be having some more webinars in the coming months. If we don't talk to you before the end of the year, hope you all have a great festive season, and we'll look forward to seeing you in the new year. Thanks, gang.